so on 436. This is A3. Two main theorems today. First one is side-side-side similarity. Now, when we refer to the side-side-side similarity, we have to be specific, because if you don't mention the similarity part, then you're talking about the congruency theorem that we have, the side-side-side. So when we refer to this, we're going to use, you either need to write SSS similarity or SSS with the similarity sign. Okay, if we don't have that similarity sign, we are talking about the congruency one from chapter 5. So we got to be careful on that. Okay, it's got to be SSS similarity that we're talking about. So the idea is very similar to that congruency one that we had. The congruency one, of course, said if all three sides are congruent, then the triangles are congruent. But now we're saying if all three sides are proportional, then the triangles are similar. Okay, so if they are proportional, meaning if we can set up that proportion and all three simplify down to the same scale factor, then we can say that the triangles are similar. Okay, not knowing anything about the angles. We don't need to know anything about angles for this. We just need to know all three pairs of sides have the same scale factor when they're simplified down. So right, that would be, you know, if we're looking at 6, 8, and 10, and this is 3, 4, and 5. Right? They all simplify down to the same thing, either to 2 or 1/2, depending on how you write it. And so since all three simplify down to the same fraction, they are proportional, meaning the triangles are similar. So that's really what you're doing, is you're taking those corresponding sides, making a fraction out of it, seeing if all three of those fractions simplify down to the same thing. Or if you don't want to simplify it, then divide it. And do they all divide down to the same decimal or the same fraction or whatever? Okay. As long as all three show you the same thing, then we're good. Okay, so our question here is either DEF or GHJ similar to ABC. So we want it similar to this one. So you're gonna have to look, you're gonna have to match up. They color coded it, so it's a little bit easier. Think about which one is gonna be similar. Go ahead, talk to somebody about it. Which one is similar? How do we know it's similar? Right? Talk about it.
DEF is equal to AF.
Similar.
Yeah.
No. Oh my gosh. I'm not
All right. What do we have here? What's going on with this one? Weston?
DEF is similar to ABC
Okay, why?
because 16 and 12 have, if you divide 16 and 12 it's 1 1/3, and then if you divide 12 and 9 it's 1 1/3, and 8 and 6 it's 1 1/3.
Perfect. Yeah. So each one of those gives you the same thing. So you can divide it, or you can simplify the fraction. You can put the small one over the big one over the small one. Doesn't matter as long as you're showing and we know that they're all the same. What's wrong with GHJ? What's wrong with that one? Yeah.
It has two of the same size as ABC, but one's different.
Yeah. So yeah, you got two of the same. If the third one was the same, they would be similar. If triangles are congruent, they're also similar. Okay, because the proportion is still there. All right, it's just a scale factor of 1. So if they're congruent, they're still similar. They're still considered similar. But the problem here is You got 8 and 16 that work, but the 12 and 10, of course, are not equal. So that one doesn't work. So it'll be the middle one, BEF, is similar to ABC. All right. Yep. Okay, same sort of problem that we've seen, and we've seen this throughout the year, right? Where it's the same type of question is worded differently. Now, it's what value of X will make these triangles similar? So we need to set up a proportion to be able to solve for X. Now, I want you to go ahead and set up a proportion. A couple different ways you can do it. What proportion would you set up here to be able to solve for X? Like I said, a lot of different ways that you can set this up. Definitely one way that's gonna be easier than the others, just because it's less stuff. Tell the person next to you, what did you do? What did you set up?
Brandon, what'd you get?
I did it in a way.
All right, here we go. Here we go. Like I said, I know there are other ways, but what proportion could we set up? What proportion could we set up here? Haley? Yeah, so 4/12, 4/12 match up, X minus 1/18 match up, we can set that up, we can cross multiply, we can solve it. Okay, and we can do that, we're gonna get X is 7, right? The other way, right, and these are the kind of those shortcuts that if we see it, great, if we don't, then set up the proportion. As you can see the scale factor is 3 or 1/3, depending on which way you're going. So if you use that and we say, all right, I divided by 3 to get here, I'm dividing by 3 to get here. If I do 16 divided by 3, that means this section needs to equal 6. 18 divided by 3 gives us 6, right? So then X would have to be 7 to make that whole side equal 6. Okay, so again, if you see that, perfectly okay to use that method, that logic, but this is always going to work for you, setting up that proportion. Okay. All right, questions on SSS similarity? All right, we move on to SAS similarity. So again, we need the similar sign, similar symbol, or we need to say the word similarity in there. So it should be SAS similarity. We're looking SAS similarity. And so just like, again, just like the congruent one, we're looking side angle side, but the sides are not congruent, the sides are proportional. So now we're talking 2 pairs of sides are proportional. We don't know all 3 sides, we know 2 pairs of sides are proportional. But the included angle between those 2 pairs of sides, the included angle is congruent. So we still need to know those 3 pieces of information. It's just, we got 1 pair of congruent angles and then 2 pairs of proportional sides. Remember, sides are not similar. So if they ever ask you, why you can use SAS similarity. You cannot say the sides are similar. Okay, the sides are proportional. The angle is congruent. The triangles are similar. Okay, a lot of different words thrown in. Okay,
Is there like a symbol or something to show that there's a person? Like there's a triangle for parallel?
no, no, there's no symbol. You would have to set up and show the proportion itself. Yeah. All right, so if we saw this, right, we know those are congruent. The two sides that would have to be proportional, we'd have to be looking at the two around that angle, the two that form that angle. So that could be 15 and 10, and then 9 and 6. I drew those in the wrong spots, but the point for me. Okay, so as long as you have those proportions for those two pairs of sides, you got the included angle. It's got to be the included angle, otherwise it doesn't work. All right, we talked about that a lot in chapter 5. It's got to be the included angle. And then those two pairs of sides are proportional. So we can create that proportion. The scale factors are the same. Then that's enough to say that they're similar. That's tough.
And also this one could be saved for the larger one. YZ would have to be between 6 and, sorry, greater than 6, but less than 20.
24. Yeah, we would know that. Yeah, because that triangle or triangle inequality there. Yep. That's not going to help us in the problem, but yeah. We can. Okay, any questions on SAS similarity? So it's going to be the same sort of idea here. Right, real world situation. We love our real world situations. Because you never know when you're going to be building a lean-to. Right, starting from a tree branch. So it says, can you construct a right end so it's similar to the left end using the angle measure and the length shown? You know, it's kind of hard to see these numbers, but that's a 6, that's a 9, that's a 15, 53. Basically, they're asking, are those two triangles similar? Are they similar?
Yes.
Okay. Yeah, you got 53 degrees, that's the included angle, right? And then your proportion, your sides are proportional. 15 over 10 is 3 over 2. 9 over 6 is 3 over 2. When you simplify. Yeah, so that would work. Right? And really that's what we're looking at today is just setting up those proportions, showing that they are proportional, showing that you've got that included angle congruent. Right? There's not a lot more to this section than these two here. So we have just kind of recap our 3 theorems from the last couple days. Okay, you got these up here. I want you to recap those 3 theorems with somebody, please. What do we know about those 3 theorems? How do you? Okay, any questions on those? All right, I told you no proofs in here, but I do want to point out a proof. This is proving the slope of perpendicular lines theorem. Just wanted to point it out, let you look at it, because it is the longest proof that you're going to see.
Not doing it. You don't have to write this.
27. 27. No, we don't have to do it. I just wanted to show you. Make you thankful that we don't have to do 20 step proof.
I'm not doing, what's the question?
I'd rather,
You're trying to prove a theorem.
Those whole.
I'd rather,
Yeah.
I'd rather just take.
They're proving that the slopes of perpendicular lines multiply together to equal -1. You kidding me? I don't want to grade 20 steps of proof.
So then we'll attempt, we get 100.
That's not it.
You could just.
Random.
Yeah.
Proper